Bismillahirrahmanirrahim. Welcome to the third lecture of physics. So today we are going to be study about motion, speed, acceleration and velocity. So the first thing is motion along a straight line. So motion, what is motion? The first thing which is more important. So let's see a simple definition. When object is going to change the position, let's see the object was at point A. Now when this object is going to change the position, let's see, this is your car and this object is going to change its position from point A to point B. This is called motion. So your car will be here now. So this is motion. So we will study about motion, position and displacement, average velocity and average speed, instantaneous velocity and speed, constant acceleration, free fall acceleration, etc. So this is a very interesting topic and very easy topic as well, because you study that in your school. So now coming to the thing, what is motion? This will help you. So one another definition, this was motion. So what is rest now? Definition of. So coming to some basic quantities in kinematics. Kinematics is a branch of physics where we can study displacement, velocity, time and acceleration. So you need to be remember four basic quantities in kinematics is displacement, velocity, time and acceleration. So one by one we will study here. So now coming to the one dimensional position. So do you know about one dimension? This is so simple topic, that's why I am just thoroughly telling you. So now coming to the quantities in a motion, which is displacement, velocity and acceleration. So coming to first one, displacement. So simplest definition is so now coming to the displacement. What is displacement? So the simplest definition of displacement is that the shortest distance between 2 points. What? The shortest distance between 2 points. Let's see, this is your shortest distance. So the shortest distance between a 2 point is called displacement. So one another thing we know about distance. What is distance? So this is your point A. Let's see, this is your point B. So the object is going from this way like this, going, then it will reach to here. So this is the actual distance. Like somebody is going from point A to point B in a car or bicycle. So they will take a square of the road and move in a straight like so. That will the actual distance. So what is distance? Because we have two terms, distance and displacement, both have a different definition. So distance, what is the actual distance covered from point A to point B? This is actual distance. And what is displacement? The shortest distance between a 2 points. So what does it mean? Like you have a plane. So in a plane you will be moved from point A to point B directly like this way. This is your displacement and this is your distance, the actual distance. Actual distance from point A to point B is called a distance. So displacement is a change of the position at time and can be represented by 2 points, like this is your x2 minus x1. This is your, so x1 and x2, what is your displacement? The change. So subtract from x2 minus x1. So that will be your displacement. So one thing keep in mind, in a displacement you saw that before, it like directed. So it needs a direction. So displacement is a vector quantity, so we can represent displacement by d with the vector sign. We can also represent displacement by s with the vector sign. So this is called displacement. So, and displacement is a vector quantity, keep in mind, but distance is a scalar quantity. So no need to write any kind of arrow because distance is a scalar quantity, and we can represent distance by d, we can represent distance by s, so without arrow because it's a scalar quantity. So now coming to distance and position time graph. So which is, now we are going to make a comparison between distance and displacement. Let's see, the object is starting from point A to point C. Okay, so first of all we are going to find displacement. What? Displacement. So we want to find a displacement from point A to point B first. Okay, basically we are going to find from A to C. So but this is a step, the object will go from point A to point B first. So from A to B, so there is a change, so the change is xb minus xa. So xb is equal to 52, this is a 52, then xa is equal to around about, xa is around about 30, so it will be 22 meter. Okay, so from A to B displacement is 22. Then from A to C, because we are talking about displacement, so in the displacement we are going directly because it's a vector quantity, A to B and A to C. Okay, so now find A to C. So xc minus xa. So xc, if you can see this xc, so this xc is equal to around about 38. So 38 minus 30, which is equal to 8 meter. So we have two values now. From A to C we have two value, so you can see this one. So this is a displacement. So now we are going to find distance. So distance from point A to point B. So in a distance, you know, we will be start from this way and then coming to here. So again the same way, the distance from A to B. So d xb minus xa, which is same, xb minus xa, 52 minus 30, 22, it's okay. But now we are going to find, because we are going to find from A to C. So this is your C. So we are going from this way, then start here. So your end is, so this is your B. So we need to find from A to C. So we will go from here, then go from there. So A to C mean, so A from our first we will be cover A to B, then we will cover B to C. So this is kind of this is the way how we can. So now we can see here from A to B, it's okay. Now from A to C, now A to C. So A to C mean that we have a two value. This is A to B, then B to C. So xb minus xa, then plus xc minus xb, two values, this one then this one. This is A to C now. So hope you will be understand that. So 22 we already find, then xc minus, then around it's 36 meters. So now 22 it's fine, but this value is going to change. So it means that displacement will always be less than the distance, because in a displacement we are going straight, like you are traveling in a plane. So that's called displacement. When you are traveling in a car, in a bicycle, or by your foot, by walking, so there will be a distance. So keep in mind, displacement is not a distance. Keep in mind always, which is more important. So now coming to the velocity. So first of all we need to study about speed. So what is speed first? Let's see here. So speed is equal to distance covered by per unit time. This is the distance, not the displacement. So distance covered by per unit time is called speed. Same definition for a velocity, but for a velocity we will use displacement. So now just learn about speed. Now what is speed? Distance covered by a body. Like you have a point A and point B, so object will cover distance from point A to point B. So this is speed. So we also have a average speed. What is average speed? So we can represent speed by V. So we have a average speed now. So average we can represent by this value. So total distance covered by object divided by total time. This is called average, taking all the distance divided by total time. This is average speed. So we also have a instantaneous speed. What's instantaneous speed? Instantaneous speed means that we can see clear here, like instantaneous speed is that a distance covered by an object in a very short interval of time. What does it mean? Like limit time approach to 0, distance covered by an object in a very short interval of time. What does it mean? This t is nearly equal to 0. So very short interval of time. In a short interval of time, object is going to cover a distance. This is called instantaneous speed. We also have a uniform speed. Uniform speed. So uniform speed is, let's see again the same formula for again here, d by t. So let's see, we have a three thing, like we have a distance, we have a time, and we have a speed. Now d by t. Let's see, in first 2 seconds it's cover 5 meter, then after 2 seconds it's just like 10 meter. For us it will be simple now. Then after 2 seconds again it will cover 10 meter again, then after 2 seconds it cover 10 meter again, then after 2 seconds it cover, it's a second again it's cover. So in equal interval of a time, or the object will cover a equal distance. What is uniform speed? That in equal interval of a time, the object will cover a equal distance. So now we can find the speed now. So speed means 10 by 2, which is equal to 5, so meter per second. Then again 10 by 2, 5 meter per second. So if you can see, your result is same, your result is constant. Now again it will be 5 meter per second. So when your result is constant, it means your speed is uniform. So what is uniform speed? That object will cover a equal distance in equal interval of time. This is called uniform speed. So this was about the speed. So now coming back to the lecture. Now coming to velocity. What is velocity? So the velocity means that velocity is, velocity represented by v again, but velocity is a vector quantity. So that's why we use this. So what does it mean? What is the definition of velocity? That a displacement covered by a body in a unit time. Now this is a displacement. In a speed we use distance, and a velocity we use displacement. So a displacement covered by an object in a unit time. This is called velocity. So velocity is the rate of change of position. So you can be also defined like that, but you need to be defined that velocity is a vector quantity. So vector quantity means that velocity will have a magnitude and direction. We studied that. So what is the unit of velocity? So the same unit for speed here as again. So d is the basically length, its distance or displacement, so represented by meter and second. Okay, so now coming to the average velocity, average speed, we study about instantaneous velocity and so on. So the same definition again we will be apply here for the average velocity. So what is average velocity? That the total displacement, covered by a body in a total interval of time. This is called average velocity. Total displacement covered by an object in a total interval of time. This is called average velocity. Keep in mind. So coming to instantaneous velocity now. Again the same definition. That object will cover a displacement in a very short interval of time and time will reach to 0. This is called instantaneous velocity. The same definition we studied in speed, so the same definition will be here, but just replace distance by displacement. So this is instantaneous velocity. Now coming to uniform velocity. What is uniform velocity? So again, uniform velocity is like your uniform velocity. So uniform velocity means like again the same formula apply here. Okay, velocity is a vector quantity, need to represent by this is t. Okay, replace it again. This is t. So velocity and so your displacement, your time and your velocity, which is d by t. So again in first 2 seconds the object cover a 10 meter displacement, then after 2 seconds 10 meter covered, then 2 seconds 10 meter cover. So your velocity will be equal to like again 5, unit is meter per second, again 5 meter per second, then 5 meter per second. So your output is same, so it's called uniform. After each 2 seconds your displacement is covered by object is same. So what will be the definition? That after equal interval of a time the object will cover a equal displacement. That's called uniform velocity. So average velocity is the total displacement covered by a body in a total interval of time. So this loop you can see here. So from this point to this point the object is going to cover a displacement. So if you can measure the displacement, which is equal to 6 meter, it's a total displacement. And what is the total time is 3 seconds. So 6 divided by 3 is it will be your average velocity. So you know about the SI unit of velocity, which is meter per second. No, the one thing is dimension. So now you guys need to be know about dimension. What is dimension? You can see velocity we can represent it by d by t. So just keep in mind d basically displacement, this is called length, and we represent length in a dimension by capital L with the this kind of bracket. This is called dimension. And this is time, so we can represent time in a dimension by capital T. So what is the dimension of velocity is now L by T. Same, the dimension of speed again it will be the same, because we have d and we represent d by L because it's a length and t is time. So dimension of speed and velocity is same. Okay, so dimension is simple thing. So hope you guys understand. So average speed, again the same thing, total distance divided by total time. So you can see the total distance. So this is your total distance and this is your average. So again, coming to instantaneous velocity, I told you before that a displacement covered by a body in a very short interval of time, and the dimension of velocity, instantaneous velocity, every velocity will always be same. The unit will be same because d and t is not going to change. So that's why dimension and unit will be same. So uniform velocity, I told you before that the object is going to cover a equal displacement in equal interval of time. It after each 2 seconds, the object is cover a equal displacement. After each 2 seconds, object cover a equal displacement. This is called uniform velocity. So now coming to acceleration. So what is acceleration? So acceleration, coming to here, acceleration is which is run by this, is the definition of acceleration is the rate of change of velocity. What is the rate of change of velocity? This is called acceleration. So what is average acceleration now? Average acceleration is that a total change in velocity, divided by its total change in a time. This is called average acceleration. So now instantaneous acceleration. So instantaneous acceleration is that the change in a velocity in a very short interval of time. Change in a velocity in a very short interval of time. This is called instantaneous velocity. Now uniform acceleration. So same formula will be used and the same concept again will be used. This is your velocity, this is your time, and this is your acceleration. So let's see, in a 2 second your change in velocity is like 10 meters per second. What? 10 meter per second. Then after 2 it will be 10 meter per second. Then after 2 seconds it will be 10 meter per second, because velocity is unit of velocity is meter per second. So it's the velocity. So in acceleration now, 10 divided, so acceleration velocity is 10 meter per second divided by 2 seconds. So this will be 5 meter will be meter, second would multiply with seconds, so it should be meter per second square. So what is the unit of acceleration is meter per second square. Again the second one, divide 10, again it will be 5 meter per second square. So this is called uniform acceleration. So now coming to the slides, you will study here. So you can see what is acceleration, changing velocity. So what is acceleration? Is the rate of change of velocity. Acceleration is a vector quantity. Acceleration is a vector quantity. Vector quantity mean will have a magnitude and direction. Unit of acceleration is meter per second square. So the formula is change in a velocity in a change in a time. So instantaneous acceleration is that a change in velocity is in a very short interval of time. So it's very easy. So this is your average acceleration, total change in a velocity divided by total change in a time. Just write an arrow on the velocity, because it's a vector quantity. So this equation we will prove it later on. Vf is equal to vi plus at. It's a equation of motion. Now instantaneous and uniform acceleration, we studied that. What is instantaneous? That a change in velocity in a very short interval of time. And what is uniform acceleration rate? That a change in a velocity in an equal interval of time. Yeah, you can be said that in an equal interval of time, that change in velocity will always be uniform. So here you can see the relationship between acceleration and velocity. So velocity and acceleration are the same, right? If you can see this one, so the object is moving from point A to point B. So, okay, it's moving. The object is moving from point A to point B, like this way. So velocity is going to increase. When velocity is going to increase, it means acceleration is going to increase. Velocity in this direction and acceleration is in this direction. Acceleration is uniform, like it shows that a blue arrow maintain the same length. Velocity is increase, red arrows are getting this one. So this equation we will show you later on. So positive velocity and positive acceleration. When the moves in like this way, acceleration will be positive, velocity will be positive. So again, uniform velocity shown by the red arrow maintaining the same size. This one is like a arrow, this is your blue. So acceleration equal to 0. When acceleration is going to 0, at this position, when the object is moving from this point to this point, so this is a plane surface. So in this surface, velocity is not going to change. Keep in this surface, velocity is not going to change. It means velocity is 0. So when velocity is 0, it means acceleration is 0. So keep in mind, this is very important. When velocity is 0, acceleration will be 0. So now at this stage now, acceleration and velocity are opposite direction. So why? If you can see here, acceleration is uniform, blue arrows can show maintain the same length. Velocity is decreasing and velocity is positive and acceleration is negative. So this is the another graph of relation between acceleration and velocity. So we have kinematic variable like displacement, velocity, acceleration, and we can represent a position also by this, because position and displacement or distance is the same. Like if you are going to change your position from point A to point B, it means you are covering some distance or displacement, or you are covering some for position. So we can represent by this value as well. So this is, if you can see, this is instantaneous. It can be instantaneous speed, it can be instantaneous velocity. So it is acceleration, instantaneous acceleration. It's just a symbols how we can represent. So position, velocity, acceleration. You have a position, you will have velocity, then you will have acceleration. It's just a graphical representation. So we have a 3 equation for a motion. So equation of a motion is, first one is equal to v, it means final velocity. We can represent like this, that vf is equal to vi plus at. What does it mean? That we have a point A and the object is on a point A. Okay, this is your object. The point A, it have a initial velocity, so this is vi. When its start moving from point A to point B, at point B it's a final point, so it's a vf. So when this velocity is going to change, so acceleration will be generated. So acceleration will be here, So when there is a change, it means there is a change in a time, so that's why we are using time. So Vf is equal to Vi plus At. It's the first equation of motion. So the second equation of motion is this again, Vf square minus Vi square is equal to 2as. This s is called displacement now. So again the same, from point A to point B the object is going, so it have a final velocity, it have an initial velocity. So if you can see this is just cover this one, and it will have a acceleration and it will cover some displacement as well. So this is a second equation of motion. So proof of first equation of motion. So what does it mean? That initially acceleration is constant. So we know about acceleration, we have acceleration is del v by del t. So how we can prove now equation of motion? So del v mean Vf minus Vi, Vf minus Vi divided by t. So initially, let's see, initially Vi is equal to 0. We are saying like Vi is equal to 0 fast, but we are not going to say that Vi is equal to 0, because we are going to find Vi, and we need to find a complete equation. So Vf minus, well, let's this Vf minus Vi divided t minus t naught. So t naught is equal to 0. So your V minus, so it will be your A. So just it will be here. So Vf is equal to Vi plus 80. This is your equation of first equation of motion. This is your first equation of motion. Proof of first equation of motion. How it can be, like from point A, object start moving from A to B. It will have initial velocity, it will have a final velocity, it will have an acceleration, and acceleration will be generated by change in time. So now coming to the second equation of motion, again the same one. We have velocity. Velocity means the rate of change of displacement. So displacement can be represented by you can be represented by x as well, doesn't matter. So del x by t. So x is here, and we know about average velocity. So t will be coming to average velocity is this one. So you know about average velocity. Average velocity means you need to take a two velocity Vf plus Vi divided by 2. This is mean by average velocity. So taking average velocity, average multiplied by t. So your result will be here now. So this is your second equation of motion. So now you can see here. So we have this equation that x is equal to 1/2 V naught plus V and t. V naught is Vi plus Vf is t. So we know about V now. In the first equation we defined that Vf is equal to Vi plus At. So you can put the value of V here. So put the value of V. So V naught plus At will be here. Then define the value. So x will equal to Vit plus half At square. So you can say that x is a displacement. Our displacement is equal to Vit. V naught mean initial velocity. Yeah, you can see Vit plus half At square. So now coming to the third equation of motion. So acceleration is equal to rate of change of velocity. You have a velocity Vf minus Va divided by t. This is called acceleration, and you know about t. What is t? It's very simple now. Acceleration is equal to velocity by time. So change in velocity and change in time. So just replace a here and t here. So this equation will be got. So just put the value of t. So and you know about this equation as well. So putting the values of t here, then you will got that V f or vf, yeah, v square is equal to vi square plus 2s. So at the result your equation will be like, you can put this value here. So this v is equal to vf, so vf square, this is called vi will be here, so minus vi square is equal to 2a del s. Del s means change in displacement. You can be represent x, d or s, whatever you want, just represent. So this is your third equation of motion. So now this is the example that an airplane has a lift-off speed of 30 meter per second. Which speed? Lift-off speed of 30 meter per second. After a takeoff, a run of 300 meter, what minimum constant acceleration? So you have your, this is called find because it has a lift-off. It's vf, vi 0, you have a s or x, and so what do you want? Constant acceleration. So you can use this one, you can use this as well, yeah, and you can use this as well. So just find out your acceleration. So what is the corresponding takeoff time? It means, so you need to be find the time. So if you are using this equation or this equation, in both these equation, so no time is available in equations, it means you are not going to use this and this one. You can use this equation because here is no need of time. You have a vf, you have a vi, you have a x, you can easily find a. When you can find a, so then you can use this or this equation for finding a time. So coming to the free fall acceleration. So you guys know about the free fall acceleration, which is equal to 9.8 meter per second square. So Earth's gravity provide a constant acceleration, which constant acceleration 9.8 meter per second square, which is always be constant. So in most important cases, so in the free fall acceleration is independent of mass. So this is more important. You need to be care about that in your mind, that in a free fall object is not caring about how much is your mass. It doesn't matter in a acceleration, in a free fall acceleration. Like you can see this this image, that you have a two objects, so both object will be with the same speed. It doesn't care about the mass because gravity is going to be, and gravity is going to attract the object toward itself. So magnitude of acceleration is 9.8 meter per second square because it's acceleration, so the unit will be meter per second square. So it will have a direction always toward the earth. So when you are so we have a positive acceleration and negative acceleration. So when you are going to up, like from earth to towards sky, so our acceleration will be negative. When we are coming from high towards earth, so the acceleration will be positive. So this was your third lecture. You guys can study it. So if you have any kind of a question, so you can ask. So have a good luck for your next lecture. Thank you.